obtuse angles, we have got reflex angles. Okay? Now, in trig, we have got formulae that are used to write ratios of any angle, that is, to write trigonometric ratios of any angle using a trigonometric ratio of an acute angle. Okay, remember, an acute angle is between 0 and 90 degrees. So, reduction formulae are used to simplify angles that are more than 90 degrees using acute angles between 0 and 90 degrees. Okay? So, like for example, if I give you, say, sine 270, you can use reduction formula to write sine 270 using an acute angle between 0 and 90 degrees. So, your reduction formula, they are used to reduce the trigonometric ratio of any angle to the trigonometric ratio of an acute angle. Okay? And then just now I'm going to talk about the examples. Now, the most common examples in terms of the angles and their reductions. We have got 180 plus or minus theta. We have 360 plus or minus theta. We have 90 plus or minus theta. And we also have negative angles, that is your minus theta. Okay? So we are going to talk about those formulae. Like, just to simplify things, okay? I'm going to draw my Cartesian plane. I'm going to draw my Cartesian plane. Just give me a second, I need to calibrate this. Right. So, last week I spoke about the quadrants. Right. So here we reduce, okay, trigonometric ratios of angles that are more than 90 degrees to a trigonometric ratio of an angle which is acute. So first thing, if theta is acute, if theta is just bear with me because the calibration are not working properly. Right, so I'm going to start with the following. In the first quadrant, if theta is acute, please take note that theta is acute, which means it's between 0 and 90. So if you have got 360 degrees here, let me write it this way. If I give you sine 360 degrees plus theta, okay? Whatever value of theta, as long as if it's acute, you always get sine theta. Okay? Sine 360 plus theta is equal to sine theta. Okay? Remember, this 360 plus theta it's a reflex angle. Okay? But if theta is acute, then your sine 360 plus theta will give you sine theta. Okay? Then your cosine of 360 degrees plus theta will also give you cosine of theta. Alright? And your tan, you're going to have tan 360 degrees plus theta. That will also be equal to tan theta. The reason is because 360 plus theta is also in the first quadrant. Okay? 360 plus theta is in the first quadrant. So, if this angle is acute, then this will be true. Okay? Can you take out your calculators, all of you? Okay, I just want to remind you that throughout this section, you need to bring your calculator to school. Throughout this section, you need to bring a calculator to school. Okay? As an example, I want you to choose a value of theta, let's say 25 degrees. Okay? 25 degrees. Put 25 degrees here, 25 degrees, then 25 degrees. Okay? Punch sine 360 plus 25. Do it, please. Sine 360 plus 25 degrees. You are getting a positive answer. Am I right? Am I right? Sine 360 plus 25, you are getting a positive answer. I said sine, where there is theta, then you put 25. You're getting 0.4 to 2 decimal places. Now, can you punch sine 25 degrees on its own? Punch sine 25 on its own. You're getting 0.42. Okay, so the sine of 360 plus theta, if theta is acute, is equivalent to sine of theta. Okay, so that's the first quadrant. Then, the second quadrant now, we use 180. So if theta is acute, we are going to have sine 180 degrees minus theta. This is the same as sine theta. Okay? Sine 180 minus theta is equal to sine theta. Right? Then cosine of 180 degrees minus theta is equal to minus cos theta. Okay? Now, in the second quadrant, because I'm sure you are all aware that in the second quadrant, sine is positive. That's why we end up having positive sine theta. If this theta is acute. Okay? Then cos is negative. Remember that. Cos is negative in the second quadrant. Remember last week I reminded you about the cast diagram in terms of your quadrants. Okay? So cos 180 minus theta is an obtuse angle. It's equivalent to minus cosine of theta. Okay? Because in the end we need to get a negative ratio. Okay. This year I'm not going to talk about the derivation of this reduction formula because I don't want to confuse you. Okay? Because the derivation is not examinable. This year I don't want to. Last year I did it from scratch, but this year I don't want to do it because I don't want to confuse anybody here. Right? Then you just memorize the reduction formula. Tan 180 degrees minus theta. Okay? We are using theta as our reference and it's an acute angle, so that would be equal to minus tan theta. Because in the second quadrant, tan is negative.
Then why is the top one minus?
It's not minus sign because sign is positive in the second quadrant. Remember your cast diagram. Remember the cast diagram. Is your weight up to date? I think one of the days I'm going to take your method anytime, and I won't tell you when. Anytime I'll just say, can I have your workbooks? Anytime. Okay? Alright. And now it's very easy because your parents' emails, I've got them on my email. Just locate your parents. That's all. Send an email even when I'm at home or I'm relaxed. I'll send an email. Your mother's email didn't go through, and you too. But those emails are the ones that I got on front office. Okay. Alright. Let's carry on. Alright. Then we are now in the third quadrant. Your cast diagram, can you stop that? That's why you have two breaks. Have you ever seen Mr. Chiponda eating or drinking in front of you? Have you? Alright, we are now in the third quadrant. Please don't forget your cast diagram. It's very important. You were taught last year. Okay, and I refreshed you last week. So we are now in the third quadrant. Now in the third quadrant, we are going to have sine 180 degrees plus theta, and this, because sine is negative in the third quadrant, this is equivalent to minus sine theta. And this is true when theta is acute. Okay? Then cosine of 180 degrees plus theta will be equal to. Now remember, in the third quadrant, cos is negative, so you have minus cosine of theta. And then tan, it will be tan 180 degrees plus theta. This is equivalent to tan theta, because tan is positive in the third quadrant. Okay, so we have 9 reduction formulas so far. Let's move on to the fourth quadrant. Now, in the fourth quadrant, we are going to have sine 360 degrees minus theta. Okay, because in the third quadrant, sine is negative. This is the same as minus sine theta. Cosine of 360 degrees minus theta is going to be equal to cos theta, because cos is positive in the fourth quadrant. Okay? Then for tan, it will be tan 360 degrees minus theta. This is equal to minus tan theta. Okay? So I'm done with 180 plus or minus theta, 360 plus or minus theta. Okay? Alright? Now we are going to talk about 90 plus or minus theta and the negative angle, that is minus theta. Okay? So from today, you need to go home and sit down and memorize these reduction formulae. Okay? I'm going to do some examples later. But I need to carry on now to 90 plus theta. Okay, let's move on to the next page. Then, but let's go to the question. You want to prove this, you choose an angle which is acute, put it here, put it there, put it there, and put it there, and see if you get the same thing on the left hand side using your calculator. Okay, it's not difficult. You just need to sit down and memorize it. And make sure you know your quadrants. Make sure you know your quadrants. Alright, so let's move on to the next page. Reduction formulae for 90 plus or minus theta. Okay? Reduction formula for 90 plus or minus theta. Generally, for 90 plus or minus theta, we concentrate on sine and cos. Okay? We concentrate on sine and cos. So number one, we have sine. Let me start with the minus. So 90 degrees minus theta. Okay, sine 90 minus theta is equivalent to cosine of theta. Okay, again, check out your calculator, right? Let's choose an acute angle like 30 degrees, right? Put 30 degrees here, you get sine 60, okay? And then put the 30 degrees there, you get cos 30. I hope you remember your special angles from last year. You still remember your special angles? Now, for 30 degrees, 45, 60, and 90, right? Sine 60 is square root of 3 over 2. Cos 30 is square root of 3 over 2. Yeah. So you must get the same. As long as the theta is acute, okay, that will be true. Then number 2, you have now this one here, we use it to convert cos to sine. So we can also have cos 90 degrees minus theta. This is the same as sine theta. Okay? Cos 90 minus theta is equal to sine theta. Again, if you choose any angle which is acute, substitute where there is theta there, you must get an equivalent answer. Then number 3, we have sine 90 degrees plus theta. Okay? Sine 90 degrees plus theta. This 90 plus theta is going to be in the second quadrant. Okay? It's going to be in the second quadrant. And in the second quadrant, sine is positive, but cos is negative. The good thing is we can write sine 90 plus theta using cos. And this is equivalent to cos theta. Right? Check out your calculator. Where there is theta, there put 30 degrees. Do that, please. It's better you do it so that you can see. Where there is theta, put 30 degrees. Where is your calculator? I need to take it out. So you get the same one, same answer. Right? Then number 4, cos 90 degrees plus theta. This is equivalent to. Now, 90 plus theta is in the second quadrant. Okay? But because cos of an obtuse angle is negative, that is, we are dealing with the second quadrant. Okay, we can write that using sine. But because sine is positive, to make the ratio negative, we have to put minus sine theta. Okay? Cos is negative in the second quadrant, and 90 plus theta is in the second quadrant. If you want to write it using sine, we have to put minus 30. Okay? You can test that by putting 30 degrees here, 30 degrees there. Do it, please. Right. Now, these 4, they are called cofunctions. Okay? Or you can call them correlations. Okay? They are formulae that are used to convert sine to cos or vice versa. Okay? They are called cofunctions or correlations, depending on the source that you are dealing with. So if you hear me saying cofunctions or correlations, I'll be referring to these 4 formulae. Okay? They are used to convert sine or cos to cos or sine. Okay? They illustrate the relationship between sine and cos. Alright? Then let's move on to negative angles. So, reduction formula. minus theta. Right? There are three. Number one, cos. Okay, let's start with sine. Sine minus theta. Okay? Alright, from your grade 10, in which quadrant is minus theta? From your grade 10, in which quadrant is minus theta? In which quadrant is minus theta? Remember, in trigonometry, if angles are positive, we measure them in an anti-clockwise direction. If they are negative, measure them in a what? Clockwise direction. So, in which quadrant is minus theta? Unfortunately, I never told you one of the three last year. Alright, your Cartesian plane looks like this. If we are dealing with positive theta, it will be like this. That's positive theta. Okay? When you're talking about negative theta, it's a reflection of this. So your negative theta will be in the fourth quadrant. That's minus theta. Okay? Right. Now, in the fourth quadrant, is sign positive or negative? Negative. Negative. Right. So, if sign is negative, then this is going to be minus sine theta. Okay? Then number two, cosine of minus theta is cos positive or negative in the fourth quadrant. So cos minus theta is very important. The cosine of any negative angle is equal to the cosine of that positive angle. Okay? Then number three, we have tan minus theta. This one here is equal to minus tan theta. Because in the fourth quadrant, tan is negative. Okay? So make sure you remember these three for your negative angles. Those four for your the reduction formula of 90 plus or minus theta. Okay? And these 12, okay, for other angles. Okay? Right? So you have got 12 on that I put on the calculating plate plus this 4, that's 16 plus this 3, 19. It's not very difficult. Okay? The number is not very important. Understand the concepts in terms of your cast diagram. The cast diagram is very, very important for you to understand your reduction formula. Okay? So in the next coming days, from today, when you go home, you sit down, you look at your reduction formula, your core ratios, your reduction formula for negative angles. Okay? The only way is for you to sit down and memorize. Okay? Any question?